Hey guys, and welcome to another maths challenge question. This one looks quite hard. Let's have a read of it together. Okay, so the diagram shows a circle of radius 1 touching three sides of a 2x4 rectangle. A diagonal of the rectangle intersects the circle at P and Q as shown. What is the length of the chord PQ? Okay, have a go at this yourself. Have a pause of the video, then unpause, and we'll try and work it out together. Okay, so where do we start with this question? I think the first good place to start is to draw this out and try and label any information that we know. Okay, so that's for draw. So we've got this rectangle here, and we have a circle which touches the three sides, and we have a diagonal that cuts through. Okay, and we're interested in this point here and this point here. Okay, what information can we label the diagram with? Well, we know that the circle has a radius of 1. Okay, so we could connect the center of the circle to our points. 1 and 1. Okay, what other information do we know? Well, we know that the entire length of this rectangle is 4 and the height is 2. So let's just put that in as well. That could be useful for us. Okay. Now, one interesting thing that I've spotted here is that if we create a diameter for the circle, the length of that diameter is going to be 2. 1 plus 1. Okay. And we also know that this height here is going to be 1. So what I've kind of realized is that this point Q, it's actually the midpoint of this diagonal line, and it's the midpoint of the rectangle. Okay, cool. That might be useful for us. The main thing that kind of tells me is that this line here is horizontal. The line connecting the center and the point Q is horizontal. Okay, but that really still doesn't help me find the length PQ. We need to come up with some sort of plan here. How am I possibly going to find this length PQ? Well, I know how to find lengths of triangles. Maybe this triangle could be useful for us because we've already got this length and we've got this length. If we were to know this angle here, then we could use cosine rule to get the length of the chord. Okay, problem is I don't know what that angle is, and to be honest, I don't know how to find that angle. Okay, I do know how to find this angle here though. Let's draw out this triangle here. So we've got this triangle. We know that this length here is 1, this length here is 1. We want to know this angle here, but let's find this angle first and call this angle theta. Okay, well, if we look at this Z shape here, I can see that this angle will also equal this angle here due to them being alternate angles, since this line is parallel to this line as they're both horizontal. So I actually just need to find this angle here. And that's quite easy because I've got this right angled triangle and I can use trigonometry. So let's draw that right angled triangle. Cool. So we know some of the lengths. We've got 4 here and we've got 2 here. Now, what I'm thinking is I want to find cos theta. And the reason is because later on, I'm going to be using the cosine rule. Okay, but in order to use cos theta, I need the adjacent and the hypotenuse. Well, the hypotenuse is quite easy to work out. It's just Pythagoras theorem. So let's do the square root of 4 squared plus 2 squared. That's going to be the square root of 16 plus 4, and therefore that is root 20, which is equivalent to 2 root 5. So we've got our hypotenuse, and now we can use cos theta. It's going to equal adjacent over hypotenuse, so 4 over 2 root 5. So that's just 2 over root 5. Cool. So we've got cos theta. Let's leave it like that for now because I can't find what theta is by itself since this is a non-calculator exam. Okay. But that's not what cos alpha is. I need cos alpha in order to use the cosine rule, as the length we need, the angle opposite to it, is alpha. Okay. How am I going to find cos alpha? Well, I know that alpha is going to equal 180 minus 2 theta. Since this is an isosceles triangle, so this angle here is also theta, and angles in a triangle sum to 180 degrees. Cool. So therefore we know that cos alpha is going to equal cos of 180 minus 2 theta. Cool. Now this is quite promising to me because it's just the addition formula for cosine. So what is the addition formula for cosine? It's going to be cos of 180 cos of 2 theta plus sine of 180 sine of 2 theta. Cool. Let's try and simplify this a bit. What does cos 180 equal? That's going to equal minus 1. So we're going to have minus cos 2 theta. Okay. What is sine 180? That's just going to be 0. So we can just forget about this whole expression. Cool. Now, what can we do with this? Well, we can use the double angle formula for cosine. So let's rewrite this as minus 2 cos squared theta minus 1. And since we know what cos theta equals, 2 over root 5, we can just substitute that into this in order to get cos alpha. So we've got minus 2 lots of 4 over 5 minus 1. So this is going to get me 8 over 5. Minus 1 is 3 over 5. And then minus on the outside, we're going to get minus 3 over 5. Cool. So we found what cos alpha equals. And now we can use the cosine rule. So I'm just going to rub out some of this earlier working so I can have more space. Let's use the cosine rule on this triangle in order to find this length here. So let's call this length A. So A squared equals B squared plus C squared, so that's just 1 plus 1, minus by 2 lots of BC, which is 1, cos alpha. And we know what cos alpha equals. It equals minus 3 over 5. So we can substitute that into this. So A squared is going to equal 2 minus by 2 lots of minus 3 over 5. All we have to do now is simplify the right hand side. So we have A squared equals 2 plus 6 over 5. And therefore A squared equals 16 over 5. And the final step is just to square root both sides. So A equals 4 over root 5. Cool, we found the length of PQ. And is that one of the answers? Yes, it is. It's going to be B. So B is our final answer, and we're done with the question. Cool, very fun question. The main sort of trick about all that is coming up with this triangle here and using some trigonometric rules and properties and trigonometric identities in order to find cos alpha, and that allows us to use the cosine rule. Cool. If you enjoyed the video, check out some of the other ones. Bye bye.